Hey everyone! In this video, we're going to look at some of the proofs we can do with rhombuses. I know we've been talking about quadrilaterals again for a while now, but we're just going to go through their properties quickly. So in exercise 1, it says, given that ABCD is a rhombus with the diagonal BD drawn, why must triangle ABD be congruent to triangle CDB? So just to remind ourselves, ABD would be this triangle here, and CDB would be this triangle here. So one thing that we definitely know about these two triangles when we're looking at them, they come from a rhombus. So right off the bat, one of the most popular rhombus properties are that all of the sides are congruent. So we know rhombus has 4 congruent sides. So now I already have 2 sides congruent for these 2 triangles, which is awesome. And even so, right from there, I could just take the last piece that I definitely know, and I have the reflexive property. So BD is congruent to BD by the reflexive. So my triangles have to be congruent. So triangle ABD is congruent to triangle CDB by side, side, side. And there's more than one way to prove this, right? Like I could have done it in a couple different ways. It's not the only possible way. If I do it this way, because of A, why can we conclude angle 1 is congruent to angle 2? Well, we know any corresponding part would be congruent. So we know angle 1 is congruent to angle 2. And it's from A, CP, CTC. I already knew 1 and 2 were congruent already, though, because if it was a rhombus, I also know that AB is parallel to CD, and 1 and 2 would have been those alternate interior angles. Okay, so based on B, what can we say is true about this segment? Well, we know that AB is parallel to DC, right? We have those congruent alternate interior angles. Why does it allow me to prove it's a parallelogram? Well, I already knew it was a parallelogram, but I'm just reminding us how we could prove it was a parallelogram, right? So if I have a pair of sides that are congruent and parallel, I know it's a parallelogram, but I already knew it was a parallelogram based on it being a rhombus in general. So I could say, since AB is parallel to DC and AB is congruent to DC, one pair of opposite sides, both congruent and parallel. So that's one way to prove a parallelogram every time. Obviously, we already knew it was a parallelogram in this case because if it's a rhombus, it has all those properties. But I'm just kind of going through the motions just to kind of remind ourselves how we would prove it was a parallelogram. Now over here in exercise number 2, given quadrilateral ABCD has the vertices given, prove that it's a rhombus using the distance formula. Okay, so we've done that a time or two. I'm going to plot those points. A is at 0, 6. B is at 4, -1. C is at -4, 0. And -8, 7. So we plot those points quickly. And our go-to way here, anytime we prove a rhombus, it's really the easiest way, the quickest way, is to do the distance formula 4 times. It might not be the quickest just because the distance formula is the most tedious, but we know it works every time. So AB. I'm going to plug that in. So here, subtract 4 squared plus 6 subtract negative 1 squared. I get negative 4 squared, which is 16, plus 7 squared, which is 49. So I get the square root of 65. So I know that each of the other sides should also be that, since they'd all have to be congruent, but we're kind of going to go through the motion because we do have to show all our work. 4 subtract negative 4 squared plus negative 1 subtract 0 squared. Looking at 64 plus 1. So far, so good. We've got two pairs that are 65 into the radical. CD, negative 4 subtract negative 8. Zero subtract 7. 4 squared is 16. We'll get 49. All right, 3 down, 1 to go. So last side of AD. So 0 subtract negative 8. Plus 6 subtract 7. We get 64 plus 1. And everything is good. So this is that type of proof, a coordinate geometry proof, where we have to show that those are, you have to show the math first. So here's my math to back this up. Now I make that statement of what I see from there, because so clearly I can see that all the sides are congruent. All sides being congruent is a rhombus property, so I can say, therefore, ABCD is a rhombus. So that's the first part of this. So it's one way I could prove that it is a rhombus, right? That's usually my go-to way. Even if we get stuck on distance formula, the more we practice it, usually that's my go-to. Now, there is another way we could have done it. So we could show that the diagonals are perpendicular. Now, in here, I'm saying it is a totally different way of proving. So I'm ignoring everything in part A for a second. I'm pretending like I didn't just do it. So I'm just talking about a different way I can prove that I have a rhombus. So I can't just show that the diagonals are perpendicular, unfortunately, because there's other shapes out there that do have perpendicular diagonals that aren't a rhombus. So it doesn't really limit it down enough. So what I would have to do first is show that it's a parallelogram. So I'm going to look at all the sides. I'm going to look at AB, and I look at the slope there. So the slope of AB is down 7 over 4. Okay, we're going to look at BC. Down 1 over 9. CD. Oh, now that I'm looking at it, I put C at that wrong spot. So let me just go fix that real quick. So this is why you kind of check as you go. So negative 4, C should have been there. It looks like I had it at the 5 spot. Sorry about that. But as I calculate that slope, I'd again get down 7 over 4. So notice I saw something was not right. I was not getting the right counting, so I was able to fix that because I'm looking at it to be a parallelogram. I'm trying to prove it is a rhombus, so it'd have to be a parallelogram to start. And then down 1 over 9 again. Geez, I am not having my best counting moment on that one. So those should have been down 8, because then I had to fix that BC because of my C moving. Okay. So when I count all of those finally, make sure that they all match up here. So I know to start that now I can say that opposite sides are parallel. Therefore, ABCD is a parallelogram. Now, we know it's a parallelogram. We want to show it's got more properties so that it is a rhombus. So when I talk about those perpendicular diagonals, now when I draw that in here, I could look at those two. AC has the slope of 6/4, simplifies to 3/2. BD is a negative 8/12. So we get a negative 2/3. So I see perpendicular, so I can say AC is perpendicular to BD. Diagonals are perpendicular. Therefore, ABCD is a rhombus, right? I now know it's a parallelogram with perpendicular diagonals. So I have all those parallelogram properties in mind, and I take it a step further. So now I can do that. So again, you can't say it's a rhombus just on the perpendicular diagonals alone, but you can say it if you show its parallelogram first. So both A and B are two separate ways to prove that a shape is a rhombus. Both totally acceptable. If you like slope and you want to do that, that's totally fine. Notice even I made a kind of mistake when I plotted, so it kind of switched me up there, but you look for them to be the opposite sides, see where that mistake is, and just kind of fix it. Okay? Now, when we do the formal statement reason proofs, the only thing we know to start here is that RSTU is a rhombus. Okay, that's the only piece of given information I have. And then let's look at the two that I want to prove. So I know I have RSU. So we have to think about what properties we know definitely exist for a rhombus. So again, just like on the last page, one thing we definitely know is that all sides are congruent. So I could say all 4 of them. I really care about the ones in the triangles that I'm trying to prove. So RS is congruent to RU. Oops. Because a rhombus has 4 congruent sides. Something about the reasoning, just those rhombus properties. But it's a rhombus property. We already know it's rhombus, so it's nothing fancy. We're just stating the property there. Okay. Okay, now there's a bunch of different ways you can do this proof. Okay. So again, just like back when we first started proofs, there's so many different ways you can do them. I'm just going to do it the way I see it first. Okay, so I might automatically notice that reflexive property, right? So I have RU congruent to RW congruent to RW. And then finally, I know that in a rhombus, the diagonals are perpendicular, making these 2 angles congruent. Remember, we can label those angles. So angles 1 and 2 are congruent. So a rhombus has perpendicular diagonals, creating congruent right angles. Right, we still want to know what perpendicular means. We still want to be specific there. So I have to have both those parts in there. But the rhombus has perpendicular diagonals. If we want to do in separate steps, we could just state RT is perpendicular to US. But really the idea of that perpendicular piece is knowing that it's going to lead me to my right angles. So we know perpendicular lines form right angles, so I can combine them in one. Again, if you wanted it to be 2 separate steps, that's fine too. But I got my 3 checks, right? So I know that triangle RWS is congruent to triangle RWU. This one's HL, so it's been a while. But if I look at it, I have a right angle. I had this side and this side. It would spale out angle side side. Not okay. Keep in mind that that is definitely not okay. But we could use HL because it's a right triangle, so it's got a hypotenuse and a leg. Something else to consider that you could have done, we could have incorporated the sides here, UW and WS, because diagonals bisect each other. You could have really got to these angles eventually too, but you'd have to start with like opposite angles are congruent and then the diagonals bisect each other. So it's a couple more steps in there. Same thing with those two. Those ones take a couple more steps to do, so I tried to avoid that if I can, but it would have been valid as well. But again, that's just one of the many ways you could have done this proofs. The steps don't matter the order as long as we get to our final answer. We're kind of used to something like 4 here. We've seen this one a couple times. This one's one of the more popular rhombus questions. It usually comes up on the Regents exam quite often. So we have a rhombus. It's telling me that the perimeter is 80 inches. So right off the bat, we should know that the 4 sides of a rhombus are all congruent. So that being said, I can just divide that by 4, and I would have 20 all the way around. Now, because it says the word explain, I would usually make sure I'd have the words written down here. I'm going to skip it in this one, but you'd have something right there that said that all the sides were congruent. Okay, if the longer diagonal here is 32, explain why the shorter one must be 24. Well, we'd also want to talk about in that explain that all the diagonals, the diagonals are perpendicular and they bisect each other. So since they're bisected, we're looking at 16, 16, 24. Oops, sorry. 12. 12, cut that 24 in half. And then we would just verify that the right triangle checks out. So I could do 12 squared plus 16 squared equals 20 squared. We end up with 400 equals 400, so we know it checks out. But in that explanation pattern, like the explanation I would have to write down, I would have to have words written on this page. When I do that, I would say that I would talk about the rhombus properties that I used here, that all the sides are congruent and that the diagonals are perpendicular bisectors of each other. Those 2 ideas would be your explanation that you needed. Now, 5's a challenge question. 5 was a part 4 Regents question, so it's going to necessarily be a harder question. This is like one of the first real part 4s that we're going to talk about. Now, I wouldn't expect anything like this on our in-class test. This is one of those harder kind of questions, but I just wanted to show it to you. Okay? So we're given that's a quadrilateral ABCD. Notice it did not give me anything I could use properties for yet. It didn't say what type of quadrilateral it is, so I can't use any of those properties until I figure out which one it is. It's got the diagonals that bisect each other, and angle 1 and angle 2 are congruent. And the first thing I want to prove is that I have an isosceles triangle. So for here, I'm going to skip the given just because I want to get right into this here. But think about it. A quadrilateral, a 4-sided shape that's diagonals bisect each other. So now at least I know it's a parallelogram. So at least I know it's got to be a parallelogram because the diagonals bisect each other. But I also have this extra piece. Angles 1 and 2 are congruent. That means this diagonal AC bisected that angle A. So a parallelogram with diagonals bisecting the angles, that means it has to be a rhombus. So I could have done that in two separate steps, say why it's a parallelogram and then say why it's a rhombus. But if I jump in here, A, B, C, D is a rhombus. That's going to be the first step that I say. The reason is quadrilateral with diagonals that bisect each other and the angles is a rhombus. Okay, so that just has to be the case. So if it's quadrilateral with diagonals that bisect each other and the angles, it's a rhombus. So now I've gotten really close to showing what I wanted to show, because if I start with this piece about ACD being an isosceles triangle, so I'm going to start with the first part. I'm going to just tackle piece by piece here. We know an isosceles triangle has two congruent sides and two congruent base angles. So I want to see what I can show here. So if I tackle that ACD, if I know that it's a rhombus, now I know that these two sides have to be congruent. AD is congruent to CD. Okay, a rhombus has all congruent sides. And then that I could jump right in. Triangle ACD is isosceles is two congruent sides, right? If you know a triangle with two congruent sides, it's got to be isosceles. So I'm already done with this part now. So 4 steps later, got that first part tackled. To finish this, though, we want to show that it's a right triangle. So now this is a different triangle, AEB, so it's a separate part of the proof. We have to think about what's the only thing a right triangle needs. Well, the only thing is that it needs a right angle. So if it needs a right angle, it's likely going to be here, and we can show that. So I can say angle AEB is a right angle. Because diagonals in a rhombus are perpendicular, forming right angles. Okay, and that being said, I can finish that off then. Triangle AEB is a right triangle because it's a right angle. Now, I know this question's not one that comes easy. This is a weird one. This was one of the hardest questions of a part 4 because it does have that proof and that ability to make sure you can kind of figure that out on your own. So I wouldn't expect to have to do that on your own, but I wanted to show it to you because it was a Regents question and show you how to tackle it. This problem wasn't hard when you were able to identify that first part of the rhombus. So I would look to see what kind of context clues they're giving me to try to figure out why I knew it had to be a rhombus, like in the beginning. And I could have talked about being a parallelogram first in building, but if I see isosceles triangle, I know I need two sides congruent. Those sides were likely the ones on the edge there of the shape. So that's how I kind of contacted way my through that. Okay. Okay, guys, we're going to do more practice with this in class. and I will see you soon. Okay, thanks for watching.